Okay, so we're looking at differential equations, part 1 video. We're going to do a few videos in this, and this is of the form that you've actually been doing lots of times. So the derivative is a function. Okay, so it actually looks complicated, but it's actually what you've been doing already. Okay, so we've got find the general solution. So general solution means we're just going to put a plus c at the end. Okay, so to go back from dy dx to y, we just integrate 2x plus square root 1 minus x squared dx. Okay, and then the integral of 2x is 2x squared on 2, which I'll fix up in a sec, and the integral of plus 1 over that is sine minus 1 x, and then plus c, and so the answer is just x squared plus sine minus 1 x plus c. So this is really what you've been doing for a long time. Okay, copy that and come across. Okay, so if the derivative equals that function and h4 equals 1, find ht. So this information over here is going to help us find the value of c. Okay, that's all it's helping us there. Okay, so first thing we do is the letter h equals integral of t over t squared plus 9, and with respect to t, so we've got dt. So you might recognize this might be a tan minus function, so we'll do it by substitution. So du dt equals 2t. So we need to have 2t on the top. So basically, I'll change colours. I've got a half. So I've got a half of 2t over t squared plus 9 dt, which is a half of du dt over square root of u. Okay, dt. So it's actually not going to be a tan minus 1 function, it's just going to be an f dash x function. Dt, and then the dt's cancel out. So I've got a half 1 over root u du, so it's not tan minus 1. So I've got a half integral u to the minus a half du, so I've got a half, add 1 to the power, divide by the power, plus c. The halves cancel out, so I've just got u to the half plus c. Away, yes, get it. Plus c equals t squared plus 9 plus c. Then this information at the top comes back in, h4 equals 1. So h4 equals 1. So that's your t value. What's your value of the function? So we've got 1 equals the square root of 16 plus 9 plus c, square root of 25 plus c, 5 plus c, c equals minus 4. And so your function is h equals t squared plus 9 minus 4. Okay, so that was not even a log function, it was just a straight substitution. Okay, come across when you're ready. Okay, next one, the rate of change in area is modeled by a differential equation. Okay, blah, 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 blah. So it's a function. This information helps us find c. And then once we've got that formula, then we're going to make a substitution to finish it off. Okay, so a equals 0.02t plus 0.5 sine pi t on 6 dt. So that equals 0.2t squared on 2 plus 0.5. Now, sine goes to cos, cos goes to minus sine, and we're integrating, so sine goes back to minus cos, so that plus sine is going to be a minus, and this will turn into cos pi t on 6, and then we have to divide by the derivative, which is going to be pi on 6. Okay, so we divide by the derivative of that, which is going to be pi on 6, sorry. And then we just put here plus c, and then we just tidy up. 01 t squared. That 6 is going to come up and make a 3, so minus 3 cos pi t on 6 in brackets over pi plus c. Then we use this value 0.3 when t equals 0. Okay, so we've got 0 minus 3 cos 0 over pi plus c. Cos of 0 is 1. So c equals 0.3 plus 3 over pi. And you can leave it like that, or approximately, according to my calculator, 1.255. But that's the exact answer if you want. Okay. So let's write the formula out again. So a equals 0.01 t squared minus 3 cos pi t over 6 over pi. Let's 1.255, and it's your formula, and then t equals 9 up the top. 0.1 9 squared minus 3 cos pi times 9 over 6 over pi plus 1.255. So that number is 80.81. This is 3 pi on 2. Cos of 3 pi on 2 is 0, so that's just going to be 0 plus 1.255. And so the answer is 2065. And the units, I think the units at the top were meters, so this is area, so it's meters squared. Okay, and I'll have an exercise up for you from that book. Okay, that's it. Bye.